Hi, so today we're talking about dilutions, and in dilutions are when you take something and add something like water to it to make it weaker. Now this is going to come in handy in any biotechnology labs that you might be working in, any chemistry labs, and it also will apply to your math classes because we work in dilutions and proportions in math as well. Now, when you add a solvent like water to something to make it weaker, then that is a dilution. So the solvent, like the water in a dilution, is called a diluent. And when you're diluting something in a lab, you're going to usually be diluting a stock solution, which is a very highly concentrated solution of whatever the active ingredient is that you need. And you need to add water to it to dilute it down to end up getting the correct amount that you need for whatever experiment you're working on. Now, a dilution is written in a fraction form. There's the stock amount over the total volume. The stock amount would be what it is you're going to dilute. If you have like 1 mole of hydroxide, and then the total volume would be what you end up with at the end, the entire amount that you end up with after you've diluted it. So this could also be called the solute, what you're going to dilute, over the solute plus the dilutant. So if you have the water, the dilutant would be water here, and the solute would be the stock solution that you use. So this would be water plus the stock, the total equals total. And that's on the bottom of the fraction. And on the top of the fraction, you just write the amount of stock that you are diluting. And you use volumes when you can, or amounts. If you're using something like powder, you can use milligrams or something. But if you're using water, then you can use milliliters. Now, a really great example of this is making orange juice from concentrate. That is a perfect example of preparing a dilution. You know how you take the orange juice out, you squeeze it out of the can, and it has that hard lump of orange juice kind of with a little bit of water in it. And then you take that same can and you fill it up with water 3 times and you pour that into the pitcher with the orange juice and you stir it up and you have orange juice. So as you can see here, you only need 1 can of the OJ. That would be the solute. And the 3 cans of the water, that would be the diluent. And you would have 4 total cans when you add them all together. That would be the solute plus the diluent. So now instead of cans, we have up here again, I wrote this on this next slide so you can remember 1 can of OJ plus 3 cans of water equals 4 total cans, and that's your orange juice solution that you're going to drink. Now instead of the word cans, because we're not in the lab, we're not making orange juice, we're doing other things, we just say parts. So you'd have 1 part of orange juice to 3 parts of water. Or you'd have 1 part of orange juice in a total of 4 parts total of orange juice and water. So when you say this, numerically, you could say 1:3, and that's 1 part OJ to 3 parts water. Or you could say 1 out of 4, 1/4. You could write it as a fraction. And when you're writing it as a fraction, you write the total on the bottom of the fraction, not just the amount of diluent that you're using, not just the amount of water, like when we write 1/3 up here, 1:3. The 3 is for the 3 parts of water. But down here, when you write it as a fraction, you write it differently. When you write it as a fraction, that 4 is going to be the total, which is the solute plus the water. So that would be 4 cans total, which is why we would write 1/4. Now see, when we write 1:3 up here, you would read this 1 part to 3 parts, 1 part to 3 parts. You're comparing 1 part of orange juice and 3 parts of water. So you would say 1 to 3. And when you write it like this is called a proportion. When you need a proportion, you write it with a colon. So you write the solute colon diluent. Or in this example, you would write the OJ amount colon and the water amount. Or you could write it as a fraction, and in a fraction you would write 1/4, because in a fraction you would write the solute amount over the total, the entire volume, the total volume after you get finished diluting it. So that would be the OJ plus the water. And that is called a dilution. They're the same thing. They say they have the exact same information in them. They're just written in 2 different ways. Now let's practice. Write both the proportion and the dilution for the following solutions. So right here we have 1 milliliter of stock solution combined with 4 milliliters of water. So we could write 1:4. 1 would be the stock, or the OJ, and 4 would be the diluent, or the water. Or we could write it proportionally. Now proportionally, what would we write? We would write 1/5, because 1 would be the stock, 1 part stock, or OJ, and the 5 would be the total solution that you made, which would be the OJ plus the water. So you see, you can write it as 1/4 or as 1:4 or 1/5, and you're saying the same thing. Now what about the next one? A 2 milliliter stock combined with 8 milliliters of water. So we could write 2:8. So that would be 2 parts orange juice and 8 parts water. Or if we wrote it in a fraction, what would we write? We would write 2 over 2 plus 8, which would be 2 over 10. And then we want to reduce that down to 1/5. So a dilution would be the 1/5. And now you're still saying the same thing as 2:8. It's just when you use a colon, you know that the number on the right of the colon is just the water, the amount of water. When you write a fraction, the number on the bottom is the total water plus the orange juice, the total volume that you're making. Now let's try number 3. Number 3 is 35 milliliters of stock combined with 65 milliliters of water. So we can write 35:65. Or for a fraction, we would write 35 over that same 35 plus that 65 to get the total volume, and that equals 100. We just carry this 35 over here. So 35 over 100. And if we reduce that, let's see, if we reduce that, let's see, 35 divided by 5 is 7. We would have 7, and 100 divided by 5 is 20. So reduced, that dilution would be 7/20. Now don't get these mixed up. If it's in a fraction form, it's a dilution. You call this a dilution, and the bottom number has to be the total amount. If it is with the colon, the form with a colon in it, that's called a proportion. And the end number is only the amount of the water. So I hope that helps, and check out my next video. I'll go deeper into making dilutions and calculating them.